Today we are going to be talking about another blind 75 LeetCode problem, and the specific problem that we are going to be looking at is the longest palindromic substring. So you are given a string initially, so from that string you have to find a substring which is a palindrome, and out of all the palindromic substrings you have to find out whichever string is the longest in length. So two criteria here. First of all, you have to find the string which is a substring for the original string, and then that string has to be a palindrome, and then find the maximum length of the palindrome. So if you guys remember, palindrome, I think it's very basic thing that you guys have studied in your semester 1-1 or something, that if a string reads the same both front and back, then that string is considered to be a palindrome. And in Python you can just write a simple built-in function string reverse to check whether a string is a palindrome or not. So for the purpose of this video, we're going to be following LeetCode's solution to solving this problem, and I do thank him for his elegant solution, because towards the end of the video you will see that that solution would also help us find out an answer to another blind 75 medium difficulty problem in this LeetCode, which is the palindromic substrings. Okay, so the intuition behind solving that problem is that we start at every character in the string, and then we move backwards and forwards from it. So the idea is, effectively, if we can find the middle of the string and then find out the left portion of the string and the right portion of the string, in this case this M being considered as the middle, then that would increase our probabilities of maximizing the palindromic substring. Because if you just write a simple palindrome of length 3, then you see that when you find out the middle of the palindrome, that's when you can compare the left portion with the right portion. If those two match, and then that first of all yields a palindrome, and that also provides you an easier way to maximize the length of the palindrome. Because if other characters are occurring and if they also match, then you are getting closer to hitting the jackpot of maximizing the length of the palindromes. So that is the approach that we are going to be following to solve programmatically, of course, also. So let's just dive towards the programming aspect of this problem. So we'd initialize the resultant substring as an empty string first. So let result sub str being initialized to an empty string, and let's just say the resultant length of the substring is first of all initialized to 0. Then we would run a loop to iterate over the string s. So for I in range length of s, we would initialize both left and right pointers to I. So this is our critical condition. While the left pointer is greater than and equal to 0 and right pointer is less than length of s, and most importantly what we showed here intuitively, that I'll write it again for your easier understanding, that whichever index we are at, we would try to compare its left portion with the right portion, and we'll try to keep going towards the left and right in order to maximize it. If that logic follows, then that's very well, then we are effectively moving towards finding the maximal length palindromic substring. If it doesn't, then we'll start at another index and try to maximize this. So that is the programming approach that we are trying to solve this problem. And so here, so s of l is equals to s of r. So now we have to check if this substring is actually the the maximal length palindromic substring. So a simple logic, if our current substring at this position 1 is greater than our resultant length, then we do so this is a string slicing. So effectively our substring is contained within left and right pointer, so we would slice the original string from the left till the right pointer, and then we just store its maximum length. So the resultant length would be initialized to r minus l plus 1. Okay, and as we said, we have to keep moving towards the left and keep moving towards the right. So we decrease L by 1 and then we increase R by 1. Okay, now this would work well if your palindrome is of odd length. So see here, this this string, it is of odd length, but it wouldn't work if your palindrome is a even length string. So let's say if something like so let's say if something like B is our even length palindrome, right? So in this case, if you remember our approach, effectively we are trying to reach to the middle of the string and then compare the left portion with the right portion. But for an even length string, what is the middle portion of the string? It's just a space, right? It's not a single character. So if it is not a single character, then how can we maximize the palindromic substring by moving towards the left and moving towards the right? So if we initialize the left and right pointer both to the current index for an even length substring, then our approach would not find the maximal palindromic substring. Rather, it would be confined towards just finding a character which is a palindrome in itself, because it's just a single character. So that is something that would be the problem with even length substrings if we just keep this and return the resultant substr. So for even length substrings, what LeetCode did is basically they copy pasted this logic for the odd length substrings and then initialize the right pointer to the index towards the right of the left pointer, and it always starts at an index more than the left pointer, because if that happens, then our left pointer is at here, our right pointer is at here. Moving towards a single character would provide us with following equal characters both at its left and right when this logic follows. So you can dig out more examples of even length palindromic substrings to see why the right pointer is always initialized to I plus 1, and that would be kind of better for your guys to understand why this approach should be designed for even length characters. And you can also write odd length strings, and then within those odd length strings you can write out the even length palindromic substrings, which can be the maximal length, and then you will also be able to visualize correctly why the right pointer always has to be initialized at one index more than the left pointer every time the index kind of increments. So returning the resultant substr should solve all of our test cases. Let's see. Yes, it does. So it solves all of our test cases, but we still have O of n square time complexity. I think you guys are smart enough to kind of come up with O of n time complexity solutions, and if you can comment that, then that would be better for my understanding also. Okay, moving on to how this approach can solve the another blind 75 question. So you see it's kind of similar problem, right? So given a string s, return the number of palindromic substrings in it. So before, in the previous question we were asked to return the length of the longest palindromic substring. Here they have asked to return how many palindromic substrings can occur within that given string. So as a programmer, it kind of becomes very easier to solve and kind of exciting to solve, isn't it? So we just copy this logic from here, and then we paste it here, and you see that we don't need the if condition here because we are not finding the maximal length substring, rather we are just finding the number of substrings that are possible. So we don't need this maximal comparison, and we can just correct the indent for this. We don't need the resultant length variable also, so we just remove that. So we just found out a resultant str, so we can initialize our counter to 0, and every time we find a resultant substr, we increment that counter by 1. And we do the same for even length palindromic substrings also. So we just remove this if condition here, remove the resultant length, and then fix the indent, and then put counter plus equals to 1, and finally we should return the counter. Let's see. Yep, so it solves the problem. It still again is O of n square time complexity, but it's a very elegant solution provided by LeetCode, and this provides us to easily solve other problems which are very similar to the longest palindromic substring problem. So in an interview, you guys can be prepared beforehand that the interviewer might, even if you solve the original question that is asked to you during that interview, the interviewer might just ask some follow-up questions, and then if your solution is elegant enough to solve that problem in itself, then solving those follow-up questions just becomes very straightforward. So always try to find out the optimal solution in a very smaller time complexity approach, and something that you can easily relate to programmatically, and you also, while solving the problem, you know why it is working, why it won't work, so that the answering any other follow-up questions kind of becomes easier. That is all. I expect some constructive feedback on the video, and I hope to catch you guys in the next one.